All right, get this. What if we could teach an AI to save lives using medical data from pretty much every hospital on Earth, but without that data ever leaving the hospital? I know, it sounds like something straight out of science fiction, right? But it's actually a powerful new reality called federated learning. And today, we're going to break down exactly how it's changing medicine as we know it.
Okay, so first step, we've got to understand this huge problem, this fundamental conflict that's right at the heart of modern healthcare. It's basically a massive tug of war, right? On one side, you have unlocking incredible medical potential, and on the other, you have protecting our personal privacy.
And that leads us to the big question, the one that this whole thing hinges on. How in the world can we train these incredibly powerful AI diagnostic tools on the exact information that they are legally and ethically forbidden from ever seeing directly? Think about it. On one side, you've got the incredible promise of AI, right? We're talking about models that could automatically diagnose diseases, create medicine tailored just for you, and even predict health problems before they happen. But, and this is a huge but, to do any of that, they need absolutely massive diverse sets of data. But then, on the other side, you've got the reality. Our health data is probably the most sensitive information we have. And for good reason, it's protected by really strict laws like HIPAA and GDPR. It's all locked away in these separate institutional silos that don't talk to each other. So this is where federated learning just completely changes the game. It's such a brilliant, elegant solution because it doesn't even try to break down those walls between the data silos. Instead, it just finds this incredibly clever way to learn over them. And the key, the real secret sauce here is that final phrase, without exchanging the data itself. That's everything. It's a whole new way of doing collaborative learning, where the raw, sensitive data never ever moves. It never gets put into one big central database. It's never exposed.
Okay, here's a great way to think about it. Picture a team of world-class chefs, and they're all trying to perfect a top-secret recipe. Now, their rare ingredients, that's the patient data, are super valuable and totally secret. They're never, ever going to ship those ingredients to some central kitchen. No way. Instead, each chef tries the main recipe in their own kitchen and then sends back only their cooking notes. This temperature worked better, or these spices were a total bust. The head chef then gathers up all those notes to improve the master recipe for everyone. The key part? The ingredients never, ever leave their home kitchens.
All right, so how does this actually work in the real world? It's not magic, even though it kind of sounds like it. It's actually a pretty simple, repeatable loop that's designed to protect privacy at every single step.
So here's how this cycle goes. Step 1, a central server sends out a kind of starter AI model to all the hospitals involved. Then, step 2, each hospital trains that model on its own private patient data, right there on site. Now, here comes the most important part. Step 3, the hospitals do not send back the data. I can't stress that enough. They only send back these mathematical updates, basically a bunch of anonymous numbers that represent what the model learned. Then, the server takes all those little learnings and intelligently combines them to improve the main global model. And finally, that new, smarter model gets sent back to the hospitals, and the whole cycle just keeps repeating, getting smarter each time. Now, the most common way to do this is with what's called a centralized model. You can think of the central server as a coordinator, kind of like a conductor leading an orchestra. It sends out the sheet music, the model, and then it gathers and combines all the feedback, the updates from each musician or hospital. But, and this is crucial, the conductor never sees or touches the raw data. The only real downside here is that if that central server goes down, well, the whole process stops. But there's another way to do it, a decentralized model. And with this setup, there's no central coordinator at all. The hospitals, labs, and research centers all work together directly. They share their model updates with each other, kind of like a peer-to-peer network. It's a much more robust system, but it really relies on all the participants trusting each other to collaborate. Okay, so the way the data is structured across these different places also really matters. First up is horizontal federated learning. The easiest way to picture this is like a giant spreadsheet. Imagine multiple hospitals all have the exact same columns, age, blood pressure, diagnosis, that kind of stuff. But they have completely different rows because they have completely different patients. This is by far the most common setup. And then you've got vertical federated learning. And this is where things get really interesting. This is what you use when different organizations have different pieces of the puzzle for the very same group of patients. So a hospital might have their clinical records, while an insurance company has their claims history for those same people. Federated learning can actually combine the insights from both of those data sets to build a much, much richer picture of a patient's health, all without either side ever having to share their private data with the other. It's pretty amazing. All right, so this all sounds great in theory, but let's talk about the real world. This isn't just some academic concept. It's already out there being used right now to pull off medical breakthroughs that were pretty much impossible just a few years back. So first, let's look at prognosis, which is basically the science of predicting what a disease is going to do next. We're talking about federated models learning from thousands and thousands of cases all over the world to do some incredible things. For example, helping doctors predict the oxygen needs of a COVID-19 patient days in advance, or getting way more accurate at assessing a woman's risk for breast cancer just from her mammogram. It's all about giving doctors that crucial head start. And it's a total game changer for diagnosis too, actually spotting the disease. For instance, by training on a super diverse set of CT scans from all over the globe, one federated model learned how to spot COVID-19 lung abnormalities with an accuracy that no single hospital could ever hope to achieve on its own. The same idea applies to really complex stuff, like analyzing brain scans for Alzheimer's. Basically, each local AI gets smarter and smarter by tapping into the collective experience of the entire network. Okay, but let's take a quick reality check here. As powerful as this technology is, it's not some magic bullet that solves everything. I mean, it's still a frontier technology, and that means it's got its own unique, really complex set of challenges that researchers are working around the clock to solve. So even though the raw data itself is safe, the system isn't totally foolproof. For one, there's still some security risks. Really sophisticated attacks could potentially try to reverse engineer private information from those mathematical updates that get shared. Then there's the data itself. If one hospital's data is biased for some reason, it could actually throw off the global model for everybody else. And finally, you've got logistical hurdles, like needing a ton of network bandwidth and just the headache of coordinating all the different participants. These are the big problems that scientists are tackling right now. And this really brings us to the big, mind-bending question that federated learning forces us to ask. What if the key to unlocking global health is data that never, ever has to leave home? This is a huge paradigm shift. We're talking about a future where we can have global collaboration without sacrificing local privacy. A future where we can harness the collective medical knowledge of our entire species to fight disease, all while fiercely protecting the data of every single person. It really makes you think. The most powerful health database in the world might just be one that never actually exists in any single place at all.